Possible imminent eruption of Mount Spurr in Alaska can be scary. Mount Spurr, named after Josiah Edward Spurr, a geologist and explorer with the United States Geological Survey, who led an expedition to the area in 1898, is one of Alaska's most fascinating natural wonders. This is a land at the edge of the world, where nature reveals itself with a power and grandeur rarely found elsewhere. Located about 80 miles, 130 kilometers, west of Anchorage, Alaska's largest city, Mount Spurr rises majestically to an elevation of 11,070 feet, 3,374 meters, above sea level. It is the tallest volcano in the Aleutian volcanic chain, a region that stretches for about 1,550 miles, 2,500 kilometers, along the northern edge of the Pacific Ocean and is home to over 40 active volcanoes. Beneath the expanse of Alaska, a hidden force of nature may be lurking, one so vast and powerful that its awakening could reshape our planet. The UN Arc, already notorious for its fiery volcanic activity and frequent earthquakes, might conceal one of Earth's most catastrophic secrets, a supervolcano. National Geographic reports that a group of volcanoes in the UN Islands has all the makings of potentially being part of one big supervolcano, around the same size as the massive Yellowstone caldera. The explosion of this supervolcano could be so immense that it could blanket continents in ash, plunge the world into a volcanic winter, and disrupt life as we know it. As terrifying as it may sound, this is a geological possibility we cannot ignore. But due to the region's harsh conditions and limited exploration, much about this supervolcano remains shrouded in mystery. Today, let's delve into Alaska's hidden supervolcano, exploring its unique geology, risks, and global implications. Don't forget to click on that subscribe button and like this video, as it's the best way to support this geology of the Aleutian Islands channel. The UN Islands stretch across the northern Pacific Ocean, forming a 200 m volcanic arc that connects the Alaska Peninsula to Russia's Kamchatka Peninsula. This island chain is a product of the Pacific Ring of Fire, a tectonically active region marked by frequent earthquakes and volcanic eruptions. The geological context of the Aleutian Islands is dominated by the complex interplay of plate tectonics, subduction processes, and volcanic activity, making it one of the most dynamic and intriguing regions on Earth. The Aleutian Arc is situated at the boundary where the Pacific Plate is subducting beneath the North American Plate. This subduction zone is one of the most active on the planet. As the Pacific Plate descends into the Earth's mantle, intense heat and pressure cause the overlying mantle material to melt, forming magma. This magma rises to the surface through fractures in the Earth's crust, fueling the chain of volcanoes that defines the Aleutian Islands. The Aleutian Islands are home to over 40 active volcanoes, forming part of the Greater Aleutian Volcanic Arc. These volcanoes vary in size and activity, with some like Mount Cleveland erupting frequently, while others remain dormant for centuries. The region's volcanic activity includes explosive eruptions, lava flows, and pyroclastic events, contributing to the island's rugged topography and ash-covered landscapes. Subduction zones are not only hot spots for volcanism, but also for seismic activity. The Aleutian Arc experiences numerous earthquakes ranging from small tremors to large destructive events. These seismic activities provide clues about the movement of tectonic plates and the underlying magma dynamics, offering insights into the region's geological processes. Beneath the Aleutian Volcanic Arc, scientists have identified geological features that suggest the presence of a supervolcano. Geophysical surveys reveal a massive magma chamber deep underground, comparable in size to other known supervolcanoes such as Yellowstone. Scientists have discovered that a trail of volcanic islands in the Aleutian Arc may actually be part of a single giant caldera. If so, it's possible the newly revealed volcanic giant once erupted in a blast large enough to dwarf the cataclysmic 1980 eruption of Mount St. Helens. The supervolcano in question is marked by a semicircular cluster of peaks in the UN Islands known as the Islands of the Four Mountains. These islands actually consist of 6 volcanoes long thought to be independent. The 6 peaks, including Herbert, Carlisle, Cleveland, Tanna, Oleaga, and Cagamel, may actually be a series of connected vents along the edge of a much larger volcanic caldera. To give you an idea about just how big the supervolcano is, a geophysicist at the U.S. Geological Survey's Alaska Volcano Observatory said that if the underlying behemoth had exploded in the last few thousand years, it could have disrupted civilizations around the world. To determine the true nature of the volcano, scientists examined the local geology and employed a suite of technology to study the region, including seismometers to pick up tiny tremors and chemical analysis to understand the composition of gases effusing from the ground. As they were working through the data, perplexing features kept cropping up that they only recently realized may belong to an enormous and ancient eruption. The first puzzle piece was the curious half-ring shape of the closely clustered IFM volcanoes. One explanation could be a caldera. Calderas are formed when a massive reservoir of magma suddenly empties and the overlying ground collapses, creating a vast depression in Earth's surface anywhere from 1 to 30 miles across. The formation of a caldera produces a host of fractures through which magma can then seep to the surface, so volcanic clusters are around their edges or centers. In this case, the researchers suspected that the IFM volcanoes may represent a series of connected geologic structures around the potential 12-mile-wide caldera, which they think lies hundreds of feet beneath the surface of the frigid Pacific waters. Another piece of the puzzle was the discovery of rocks known as welded ignimbrites. These materials form when a large eruption lays down searing volcanic ash so thick that the grains weld together into solid rock. If their suspicions are confirmed, the researchers believe that the potential underwater basin may have resulted from a previous supereruption. Researchers also pointed at the fact that the high and sustained emission of sulfur dioxide from the island group's central volcano and the composition of volcanic gases from the 6 volcanoes suggest a shared connection to a larger magma source. In addition to the geographic data, scientists used tiny seismometers to record multiple microearthquakes around these islands that extend farther east and north, hinting at one massive volcanic activity. The researchers cautioned that many unknowns about the structure remain. For one, they are still unsure about the size of the caldera, and they don't know whether it was made from one large blast or several smaller eruptions. The UN Islands' remote location and harsh environment pose significant challenges to geological research. Many of the islands are uninhabited or sparsely populated, with limited infrastructure such as roads, ports, or airstrips. Reaching these locations often requires specialized equipment, boats, or helicopters, which are expensive and logistically challenging to operate. The sheer distance from research facilities adds another layer of complexity, as it makes frequent expeditions costly and time-consuming. The UN Islands are also notorious for their harsh and unpredictable weather. The region is frequently battered by strong winds, heavy rainfall, and snowstorms, which can disrupt fieldwork and endanger researchers. Dense fog and low visibility often make air travel risky, while rough seas can hinder maritime operations. These weather conditions limit the duration and scope of field expeditions, forcing researchers to carefully plan their work around short weather windows. Due to these challenges and limitations, identifying and interpreting evidence of the potential supervolcano is complicated. Despite its geological significance, the Aleutian Arc has been under-researched compared to more accessible volcanic regions like Yellowstone or Hawaii. The scarcity of long-term monitoring stations limits the amount of real-time data available for analysis. This data gap hinders scientists' ability to construct detailed models of the subsurface and to detect subtle signals of volcanic or seismic activity. The hypothesis of a hidden supervolcano beneath the UN Islands in Alaska is both fascinating and concerning. If the possible discovery of a mysterious, gigantic supervolcano underneath the North Pacific scares you, the findings don't always necessarily have to point to a future catastrophe. The study team is still in the early stages of the research, and with more clues, they gain more information on the current and potential future hazards in this region, and could one day actually prevent them. As research continues, the UN Islands will undoubtedly remain a focal point for geologists, volcanologists, and disaster preparedness experts. By unraveling the mysteries of this potential supervolcano, we can better appreciate the dynamic forces shaping our world and work towards mitigating the risks associated with these awe-inspiring natural phenomena.